All right, everyone, let's jump right in. Today, we're taking a close look at Alcaligenes faecalis, a bacterium that you could say has a bit of a split personality. To give you the full picture, we've put together a detailed clinical briefing using Gemini Deep Search.
So, on the one hand, you've got this incredibly versatile organism that's, well, pretty much everywhere in the environment. We're talking soil, water, you name it. It's so metabolically gifted that people are even looking at it for cleaning up industrial waste.
But then, you've got its other side. It's also popping up as a really formidable threat inside our hospitals. It has this almost spooky ability to thrive in the damp, tough environments of hospital plumbing, which makes it a really persistent and dangerous problem for our most vulnerable patients. So how do we square these two faces of Alcaligenes faecalis? That's what we're here to do. We're going to break down everything you, as a medical microbiologist, need to know to handle this challenge, from what you're seeing at the bench all the way to your clinical consults.
We're going to follow a classic bench-to-bedside journey. We'll kick things off by understanding the clinical problem it poses. Then we'll head into the lab to see how we identify it. From there, we'll tackle the huge challenge of its resistance profile. And finally, we'll wrap up with the best strategies for infection control.
Okay, first things first, let's establish exactly why Alcaligenes faecalis should be on your radar as a serious opportunistic pathogen. You know, this organism is a classic opportunist. It's not going to bother healthy people walking down the street. It waits for a weakness. So we see it most often in our immunocompromised patients, those with indwelling devices like catheters, and folks with underlying conditions like diabetes. Neonates are also particularly at risk because their immune systems are still developing. And the kinds of infections it causes really reflect those vulnerabilities. As you can see, catheter-associated UTIs are the big one, making up a huge chunk of cases. But it can cause a whole spectrum of serious problems, from diabetic foot infections and ventilator-associated pneumonia, all the way to life-threatening bacteria and sepsis. All right, let's head over to the lab bench and walk through how this organism gets identified, from the initial workup right through to a definitive confirmation. Your initial workup is going to look pretty familiar. It's a gram-negative rod or coccobacillus, and it grows just fine on your routine media. On McConkey agar, it shows up as a non-lactose fermenter. The real key spot test here is a strong positive oxidase reaction. Oh, and here's a fun little tidbit. Some strains produce this very distinct, fruity, almost apple-like odor. Now, this is where it gets really useful at the bench. A few simple biochemical tests can help you tell it apart from other common non-fermenters. Take a look at the table. See that negative nitrate reduction? That's a huge clue to help you differentiate it from Pseudomonas aeruginosa. And then its positive motility and positive oxidase reaction really set it apart from the Acinetobacter baumannii complex. Of course, these days, for a definitive ID, modern methods are king. While 16S rRNA sequencing is still the gold standard, MALDI-TOF MS has completely revolutionized the workflow. It gives you rapid, super accurate, and cost-effective identification right from a colony, and it gets around the variability you sometimes see with the old commercial biochemical systems. And this brings us to the real elephant in the room with Alcaligenes faecalis, its complex and, frankly, increasingly scary antimicrobial resistance profile. This bug is like a sponge for resistance genes. Through horizontal gene transfer, it's just really good at picking them up from other bacteria. This means we're seeing everything from simple penicillinases all the way up to powerful ESBLs that intake out our third-generation cephalosporins. And even more worrying is the rise of carbophenerases and mobile colistin resistance genes. We're talking about threats to our absolute last-line drugs. Now here is the kicker, and this is a massive headache for every single clinical lab out there. There are no official EUCAST breakpoints specifically for Alcaligenes faecalis. This puts us in a real gray area, making it incredibly difficult to interpret and report susceptibility results with any kind of confidence. And what happens then? You get this really dangerous feedback loop. Without standardized SIR categories, reporting is all over the place from one lab to the next. This makes it almost impossible to do effective large-scale surveillance, so we might be completely missing the true scale of resistance. And that, in turn, can lead to doctors choosing the wrong empirical therapy, which just puts more pressure on the bug and accelerates the whole problem. So, with no clear breakpoints, what are we supposed to do? How do we help guide clinicians toward effective treatment? Well, we have to look at a syndromatic approach and see how we can turn our lab data into real clinical action. In this kind of situation, clinicians have to fall back on a syndromic approach, basically applying general principles for treating tricky non-fermenting gram-negatives.
For example, if we look at the Dutch SWAB guidelines for a complicated UTI, they might suggest starting with something like cefotaxium or ceftriaxone. But, and this is the most important part, that's just the starting gun. The final treatment plan must always be tailored to the specific MIC values you report for that particular isolate.
And if you think the situation is tricky for adults, for kids, it's even tougher. There are no specific guidelines. Treatment decisions have to be made on a case-by-case basis, guided entirely by the susceptibility report from your lab, and usually with an infectious diseases specialist weighing in.
Okay, so given all these treatment challenges, you can probably guess that prevention is absolutely critical. Let's look at the most effective ways to control its spread in the hospital.
The strategy here has to be about more than just the basics. Of course, you need strict hand hygiene and contact precautions for multi-drug resistant isolates. But you also have to put a heavy focus on the environment. That means meticulous cleaning, smart device stewardship, and probably most important of all, a really comprehensive water management program.
So if there is one single thing to remember, it is this. To control Alcaligenes faecalis, you have to control the environment. This isn't just about stopping patient-to-patient transmission. It's an infrastructural battle against the biofilms this thing loves to form in our hospital's water systems, in the sinks, the drains, and all over our medical equipment.
Just so you know, all the information we've walked through in this briefing was distilled from a very in-depth clinical monograph that we compiled using Gemini Deep Search.
And if you want to dive even deeper into the primary literature yourself, you can find a complete list of all the citations in the linked notebook document. We really hope this clinical briefing was valuable for your practice. Please do subscribe to our channel for more deep dives into clinically important bugs. And we'd love to hear from you. What are the biggest challenges your lab is facing with non-fermenting bacteria? Let us know and share your experiences in the comments below.